guys, this is Dr. Bob with another installment of Summer Science in the Northern Neck. Today we're going to talk about a liquid that we use every day. It's essential for life. We take it for granted, but it has amazing properties. Do you have a guess of what it might be? Nope, it's water. Water. Why do we want to talk about water? Well, water is essential for life. And water has incredible properties. For example, its boiling point is plus 100 degrees C or 212 degrees F. If we think about similar molecules like methane, ethane, propane, or even H2S, which sounds similar to H2O, all of their boiling points are well below zero. So what does that mean? Well, it means if water boiled where H2S boils at minus 76, there would be no lakes, no rivers, and no oceans on Earth. All of the water would be up there. And the plants couldn't drink, it wouldn't rain, and there'd be no life on Earth. So let's talk a little bit about this incredible substance. And what we're going to explore today is a property called surface tension. And a simple way to think about that is, how strong is the surface of the water? We've all seen it. Again, probably not thought about it, but have you ever seen an insect skating across the water on a lake or a pond? They're actually denser than the water and too heavy to float. The thing that keeps them up is the strength of the surface of the water, which we call surface tension. Now, for the older guys, this has to do with hydrogen bonding. For the younger guys, this basically means water likes itself really well, and it likes to cling to itself, and that creates a very strong surface that gives it its unusually high boiling point and unusual properties. So, how do we visualize surface tension? Well, I've put together a bunch of demos that you can do at home. Now, you're going to need a few things for these, not the least of which is mom and dad to help you. You'll need a couple of small plates, a juice glass, a paper clip, a penny, and some type of dropper. If you don't have a dropper, you can even transfer drops of water from your fingertip. We'll also need some food coloring, and that's particularly where mom and dad should be consulted. And we'll need a little bit of milk for the final demo, because milk gives us a nice white canvas to use the food coloring and to create some pretty spectacular images. So there's some video demos that are going to follow this introduction, but hopefully you won't think of water the same way after this. Have fun, guys. Let us know how it's going. If you have questions, feedback to us on the Facebook page, and we'll try to get them answered. Thanks, everybody. Have fun. Okay, so let's look at some practical examples of the surface tension or surface strength of the water. Here I've suspended a paper clip, which is more dense and too heavy to actually float, and yet the surface tension of the water is sufficient to keep it afloat. Now we're going to do this in two steps. The first step, I have a little cotton swab here, and we're just going to dip the cotton swab in the water to show you that the cotton swab itself isn't changing anything. The next thing I'm going to do is dip the cotton swab into some dish soap. So you can see it there, the blue dish soap. And then we're going to dip the cotton swab with the dish soap into the water to try to reduce the surface tension. What do you think is going to happen? Everybody have their hypothesis? Okay, let's give it a try. See if I can do this without blocking the camera. There you go. The paper clip sank to the bottom because the surface tension of the water was so greatly reduced that it could no longer support the weight. And the paper clip went where it should have gone in the first place, except that water surface is very strong. Okay, in this demonstration of surface tension, I have a shallow plate that has just plain tap water in it, and I'm going to cover the surface in pepper. You can see the pepper mill grinding away, and you can see that the pepper floats on the very strong surface of the water. Again, I'm going to take the unsoapy end of just a simple cotton swab and dip it in the water, and nothing happens. When we re-dip the cotton swab into that nice blue dish soap, let's see what happens. Do you have an idea? Do you have your hypothesis ready? Okay, let's go. Look at that. The pepper is pushed away in a wave as the surface tension is reduced. And I don't know if you can see it here, but some of the pepper is beginning to sink to the bottom. Again, we've greatly reduced the surface tension of the liquid water, and it's had an amazing effect on the pepper that we sprinkled on top. Okay, in this demonstration, we're going to take a nice, clean, shiny, dry penny and use this as a means of measuring the surface tension difference between water and soapy water. So what I want you to do is to add clean water to the penny, one drop at a time, whether you have an eyedropper or, in my case, a little spritzing bottle or some other means to add the water one drop at a time, and let's see what happens. How many drops of water can stay on the penny until it overflows? Are you counting? Okay, looks like drop number 11 caused it to fail. So what I'm going to do, rather than redo this with soapy water, is I'm going to load it back up to there. Maybe we can get one more drop on there. Two more. Okay, now I'm just going to touch it with a little bit of soapy water, and let's see what happens. See, the surface tension was reduced and the water on the penny collapsed. What I want you to do at home is to do this in two stages. One with clean water, counting the drops, and the second one with soapy water rather than the cotton swab, and count the drops on soapy water until it falls over the edge. And if you want to, you can send your results in to the Facebook page, and you can look at other people's results. Okay guys, this is maybe the funnest demo because we get to make some interesting colors. If you remember from the chromatography lesson, we got to see colors separate. And in this case, we'll need a saucer full of milk, which is what you're looking at right now, and some food colors. So make sure mom or dad are aware of what you're doing. Probably want to do this by the sink so you don't make a mess. And what we're going to do is we're going to add a couple drops of each color in a different spot. And we're going to be careful not to mix them just yet. Drop them pretty close to the surface so they don't splash. And then we're going to take our famous soapy Q-tip and we're going to break the surface tension and create kind of a kaleidoscope of colors. So check this out. Let's look at the blue and the green and the red and the yellow. And you can keep doing this until you get a pattern that you really like. So that's kind of crazy abstract art, but it's all about breaking the surface tension of the liquid and causing the colors to flow because the surface tension is broken, kind of like a wave. And you can see it's still moving, it's still undulating. You might want to have your cell phone camera around so you can take a picture of it and share it with your friends. So, but be very careful with this. We don't want to make a mess or get stains on anything. And we can just kind of back the camera off a little bit so you can see all the different colors. We can make make the red move a little more. We can make the green move a little more. There, I kind of like that.